is Yula, and today we are going to do mensuration. So this course is for completely beginners who are about to give their O-level examinations maybe next year or maybe next month or maybe after 5 to 6 months. So I'm going to give the entire syllabus of this course in the description link, and whatever we are going to do in this course, if you are in touch with the full course and also this video, you're going to get a basic kind of knowledge of solving problems in the IGCSE syllabus, and I can guarantee you, after having watched all the videos of this course, you can become an expert of solving problems. So today we are going to do mensuration. So to begin with, I'm going to give a very short definition of what mensuration is. Mensuration is basically the part of geometry or the part of shapes where we are concerned on finding area, volume and length of shapes. For example, so the very first shape I'm going to draw now is a circle. So we all know what a circle is and what a circle has as its properties, but just to give a brief notation of what a circle is, we are going to actually define the insights of what a circle has. A circle has a diameter, and what's a diameter? A diameter is basically a line, a length of a circle which actually crosses the center of the circle. The center of the circle is basically the midpoint of the circle. It's located at the very center, the equator, we can say, kind of. And a diameter is basically the length which actually passes through that center. Now, diameter has another kind of equivalent thing, which is diameter is 2 times the radius. That means a radius is half the diameter. Now, how we can actually find a radius depends on what's the question has been given on. Now, if we have a diameter which is, for example, let's say we have a diameter of 15. Now, obviously the radius will be 15 divided by 2. So this is just a very basic kind of thing we already know from circle, I guess. But what's more, we all know the area formula of a circle, which is pi r squared. Now, what is a pi? A pi is basically the ratio of a circle's circumference with the diameter. Now, if you want to know more about pi, you can just browse on your Google and actually look on its history. Normally, the value we use for pi is 22/7, which actually comes in decimal as 3.1416. Some people generally use 3.1412, which is not a problem. 3.142, which is obviously not a problem, as long as you are actually maintaining this decimals properly. You can actually get the value very easily. Now, I'm just gonna erase all of this and basically start with the main part. Alright, so we all now know about what's the diameter of a circle and what's the radius of a circle. Now let's head to another thing, which is called the chord. So what is a chord? So we know a diameter is basically a length that passes to the center of a circle and it ends on another point of the circle. For example, if this is point A, this will be point B, and this whole thing is considered as circumference. Alright, now a chord, on contrary, is basically a length which not only passes through the center of a circle, but it can actually extend from any point of the circle and end on any point of the circle, but it never intersects to the center. So that's the difference between a chord and a diameter. So to give you a better idea, this can be a chord, even this can be a chord, this can be a chord, this can be a chord. What's the difference is that it's not a diameter, is basically it does not intersect the center of a circle. A diameter intersects to the center of a circle, but a chord never does intersect to the center of a circle. Okay, now to actually have a better idea of this, we are going to use the very basic kind of saying that you'll normally hear, which is every diameter is a chord, but not every chord is a diameter. I guess most of you have heard about this simple notation, which is every diameter is a chord, but not every chord is a diameter, which is in fact true, because not every chord is obviously a diameter. As I've said before, a chord can be anything. It can pass through any point of the circle and end on any point of the circle. Now, what's the similarity that makes it like a diameter? So there are mainly two features which I generally distinguish, and that is diameter. It passes through the center of a circle and it ends on another point of the circle. That means, for example, it starts from A, it will end at B, right? Sorry, that's my bad. It starts from A, it will end at B. Similarly, a chord just does the same. It starts from A, it ends at B. But the difference is a diameter crosses through the center. It intersects through the center, which a chord does not. So that's the basic kind of difference which we have to know. Now, as we have already gathered a basic idea of what's a diameter, what's a radius, what's a circle's chord, now let's head to some formulas. And I know most of you have a very clear idea of what's the area of a circle, which is a pi r square, and the circumference, which is 2 pi r. So a circumference is basically the whole boundary of the circular region. We call this circumference, and that's the formula, which is 2 pi r. Okay, now what if, let's say, let me clear all of this. What if there's a circle which is divided into two? Sorry, my bad. So what if there's a circle which is divided into two? I'm messing it up. Alright. So what if there's a circle which is divided into two? What do we call that kind of circle? So we all know this is basically a half of a circle. And a half of a circle is basically known as the semicircle. So some people like to call it semicircle. So either way, you can actually select to call any of them. Okay, so semicircle is basically half of a circle, and we all know that the area of a semicircle is half pi r squared, and the circumference of a semicircle is 2 pi r divided by 2, which is pi r. So this is the formula for the semicircle. This is the formula for the semicircle's circumference. Now, to addition, for a semicircle, the difference is that it makes that makes it a bit different from a general circle is it has a perimeter. So a circle, it does not have a perimeter formula because it is a full circle. It has a full circumference, whereas a semicircle does not have the full circumference. It has half the circumference. That's why it has another formula, which is the perimeter of the semicircle, and that is basically by adding the 2r, the diameter of a circle. Because you see, when we are about to calculate the semicircle circumference, we are basically calculating this length, this arc. But what's with this? This is being ignored, and that's why there's an additional formula which is known as the perimeter. And a perimeter is basically the total length of the semicircle. That means a perimeter is c by 2 plus 2r, and the value of c is 2 pi r. I'm just gonna ignore the 2 for now because we have already written it here. So this is gonna be pi r plus 2r. So this much you have to know for semicircle to the extent of the O-level syllabus. And yeah, now now we are going to understand the quarter circle. So let me erase all of this stuffs and simply draw a circle. Okay. A quarter circle is 1/4 of a circle. So we already know what's a semicircle. It's basically half the circle. A quarter circle or a quadrant is basically 1/4 of the circle. That means if the circle is divided into 4 parts, then a quarter circle will be the one which is 1/4 of the entire 4 parts. Now the formula for a quarter circle's area is very easy to get into, which is pi r squared divided by 4. The circumference is pi r by 2. Basically the 2 pi r by 2 is getting cut. 2 by 4 is basically 1 by 2, so pi r by 2. And just like a semicircle, a quarter circle also has a perimeter formula, which is P equals to pi r divided by 2 plus 2r, as it has a radius. Now some people may actually confuse with the perimeter formula with the circumference formula, but to make this very clear, a circumference is basically this thing, this arc. It's not this two lengths. These two lengths are calculated on a different formula using the perimeter formula of the quarter circle. Now we have basically gathered almost everything about a circle's shapes, areas. A circle does not have a volume, so yeah, that's why we're not going on that part. But now let's actually move on a more trivial part of this course, on a more trivial part of this episode, which is the sector area and the arc length of a circle. So what's the sector area of a circle? Now I'm not going to write anything on board. I'm just going to explain this just by saying what's a sector area. Imagine you have a cake, right? Imagine you have a pie cake. Now for example, your mother gives you a slice from that cake, but that cake is not obviously a semicircle. It's not obviously a quarter circle because it's a slice. Now in what's the basic kind of thing about slice? A slice is basically a part, or basically a portion of that particular pie cake your mother has given to you. Now let's draw a circle, right? So this is a circle. Now a semicircle would be half of that circle. Now your mother has not given you half of that circle. I have told you that your mother has given you a slice. So a slice can extend from any point of the circle. This can be a slice, right? Because if you look at this is not a semicircle nor it's a quarter circle. It's a portion. So as it's a portion of the circle, we can actually consider this part, this very part, as being the slice of that cake. Now if you are being told to find the area of this portion, what formula are you going to use? So the very formula you're going to use is this: theta divided by 360 into pi r squared, and the arc length would be theta divided by 360 into 2 pi r. So the area of a sector circle, the area of the sector of a circle is theta divided by 360 into pi r squared, and the arc length of the sector of a circle is theta divided by 360 into 2 pi r. Now some of you might think it's crazy to actually go with this formula. What is this formula? Now let's actually understand the revolution of a circle. Let me erase all these things right now. Now what's a revolution? A revolution is basically 360 degrees. That means a circle consists of a revolution. Sorry, that's an irregular circle. So this circle right here is basically a revolution. So a revolution is basically 360 degrees. Now for to find the circumference of a circle, we just use the formula 2 pi r. But to find the slice, as I've said before, the sector of a circle, we don't use this formula. We don't even use 2 pi r divided by 2, or we don't even use any kind of rationalizing pattern of formula. We actually use the formula theta divided by 360. Now why we use this theta? What's this theta has? Okay, let's draw the sector. If this portion is 360 degrees, right? If this whole portion is 360 degrees, this portion just right here will not be 360 degrees. It will be a part of the 360. It would be theta divided by 360. Theta is a Greek term. If you are interested in history, you can just go in Google and browse it. So this point is considered the theta, and this point is considered the entire 360, and therefore from this particular angle we get theta divided by 360. And by just getting, if you want to get the areas formula for a sector, you just multiply with the pi r square of the circle, and to get the circumference of a circle we multiply theta divided by 360 into 2 pi r. Alright, so that's very simple, and that's the arc length formula, and that's the sector area formula. Now just like a semicircle and a quarter circle, a sector area is also has a perimeter. Now what's the perimeter? For example, we have arc length, which is theta divided by 360 into circumference of a circle, which is 2 pi r. We just add 2r. Just the same thing. For any perimeter formula, you just add 2r as an addition. So that's basically everything for sector area and arc length. The formulas, I'm now going to give all the formulas just right here. You can just note them out on your copy and understand them, because in the next video we're going to solve some trivial maths from this circle, and then we are going to move on more different shape and complete the syllabus for mensuration, and then solve IGCSE past paper problems. So I'm just gonna write all the formula right here. So yeah. guys for watching this first episode. Stay in touch with the upcoming videos, as we're going to solve more problems in upcoming videos. So the next video is basically on some IGCSE problems from the circle and whatever things we have to understand, we have to work out for our IGCSE syllabus. And yeah, that's what it is.